the ages of 300 patients getting medical treatment in a hospital on a particular day. They are given the ages in terms of class interval and the number of patients. Form less than type cumulative frequency distribution and also more than type cumulative frequency distribution. Let's do that. For less than type cumulative frequency distribution, it is clear from the previous table that the patients less than 10 years of ages are 0 and less than 20 years of ages are 60. For less than 30, it includes 10 to 30, that is plus 60 and added to 42, it becomes 102, and so on. For more than type cumulative frequency, first class interval is 10 to 20, so the more than 10 will include all the patients from the last class interval. We observe that patients are more than or equal to 70 or 0, more than or equal to 60, more than or equal to 60 or 20, and so on. So let's do that. First, let me write this side as less than type, and towards the right I'll write more than type. In the less than type, I'll make two columns. One column of age of patients, another column is number of patients. The same I'll follow in the more than type also, ages of patients and number of patients. Towards ages of patients, I'll start from less than 10. The number of patients are 0. Less than 20. The number of patients are 60 added to 0, it is 60. Less than 30. It will be 60 added to 42, 102. Less than 40, 102 to be added to the frequency 55, it becomes 157. Less than 50, it is 157 added to 70, 227. Less than 60, it is 227 added to 53, it becomes 280. And the last, less than 70, it is 280 added to 20, it becomes 300. Towards more than type, I have to consider more than or equal to 0. More than or equal to 0, it includes all the patients. So 60 added to 240, it is 300. More than or equal to 20, it is 42 added to 198, 240. More than or equal to 30, it is 55 added to 143, 198. More than or equal to 40, it is 70 added to 73, it's 143. more than or equal to 50, it is 53 added to 20, which is 73. More than or equal to 60, it is 20 added to 0, which is 20. More than or equal to 70, the number of patients are 0. This is how we'll make less than type and the more than type. Cumulative frequency table. Question number 14. Given below is a cumulative frequency distribution showing the marks secured by 50 students of a class. You have to form a frequency distribution table from this cumulative frequency table. Here, look at the marks. It's below 20, below 40, below 60, below 80, below 100. So the class size is 40 minus 20, which is 20. So I have to consider the class interval like 0 to 20, 20 to 40, and so on. So marks I'll write as a class interval, and the number of frequencies is the number of students. The class interval 0 to 20, it is 17 minus 0, which is 17. When the class interval is from 20 to 40, it is 22 minus 17, which is 5. 40 to 60, it is 29 minus 22, which is 7. 60 to 70, sorry, it's 60 to 80, it is 37 minus 29, which is 8. Next is from 80 to 100, this is 50 minus 37, which is 13. So this is a frequency table for the given cumulative frequency table. Question number 15. Weekly income of 600 families are tabulated below. You have to compute median income. Here the number of families are given, that's frequency. So we have to find the cumulative frequency. The cumulative frequency will be 250, added to 190 will be 440, added to 100 will be 540, added to 40 will be 580. Next is 595, next is 600. When class intervals cumulative frequencies are there, then we can find the median. For that, the median of this data can be found using the formula median equal to the lower limit of the median class plus n by 2 minus the cumulative frequency multiplied to the size of the class divided by frequency. So from here to here, right? Lower limit is separate. Here the lower limit of the median class is 1000. Because we need to take 600. 600 is even observation, so median will be 600, sorry, 300 and 301st observations mean. So that comes out to be in the range 1000 to 2000. So lower limit is 1000, the number of observations is 600, the cumulative frequency is 250, the class size is 1000, and the frequency is 190. Let us substitute the value. Median will be 1000 added to 600 upon 2 minus 250 multiplied to 1000 divided by 190. So the median will be 1263.15. Question number 16 is similar to the previous type of question. We have to find the cumulative frequency, and then we have to use a formula. Here I'll be giving you the direct answer. You may cross check after solving. The median is 109.17 kilometer per hour. So try this out. Use a formula. Median as lower limit plus n by 2 minus the cumulative frequency into the class size divided by the frequency. Question number 17 is related to mode. So we should remember to use the formula mode equal to the lower limit plus f1 minus f0 divided by 2 times of f1 minus f0 minus f2 multiplied to h. Here we need to identify the modal class. The class in which maximum frequency is present is called as a modal class. So the modal class is 10,000 to 15,000. So the frequency of the preceding modal class is 26, the frequency of the modal class is 41, frequency of the succeeding modal class is 16, and the lower limit of the modal class is 10,000, and the class size is 5,000. So let's substitute the value. Mode will be the lower limit, which is 10,000 plus f1 minus f0, 41 minus 26. This has to be multiplied with the class size 5,000 divided by 2 times of 41 minus f0 is 26 minus 16. Now after simplification we'll get it as 11.875. This will be not 11 point, it's 11,875 per month. This will be the amount modal income. Question number 18 is similar to the previous question, but then here they have given the frequencies. Maximum frequency is here 26. So the modal class will be 201 to 202. 201 to 202 is modal class. So when the modal class is known, we can find out the preceding frequency, the modal class frequency, succeeding frequency, the class size is 1, the lower limit of the modal class is 201. Substitute in the formula L plus f1 minus f0 into h divided by 2 times of f1 minus f2 minus f0. On substitution, we'll get it as 201. This will be in terms of gram. You can cross check. Question number 19. Two dice are thrown at the same time. Find the probability of getting same number on both dice. Different numbers on both dice. Here, when two dice are thrown at the same time, there will be 36 outcomes. The total outcomes are number of total outcomes are 36. In this, favorable outcomes for the first one, this is for the first one, that is alpha numerical 1. The favorable outcomes are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6 comma 6. So the number of favorable outcomes will be 6. So the probability of this event is 6 upon 36, which is 1 by 6. The different numbers is exactly the complementary event. So probability of getting different numbers will be 1 minus 1 by 6. This will be 5 by 6. With this, I'll conclude today's session. We shall discuss the remaining questions in the next session. Thank you.